Next Curve.
Welcome to another episode of NEXT Curve's Rethink podcast, where tech industry thought leaders discuss the trends and technologies that are shaping our digital future. And I'm Leonard Lee, Managing Director and founder of NEXT Curve. Today, I have a very good friend and VP of IoT Data Strategy at Ericsson, Rob Tiffany. How's it going, my man?
Hey, good. It's good to be here. How you doing, man?
I'm doing pretty good. I just want to tell you, I'm trying to do the Rob Tiffany here. You see that?
Careful.
How am I doing?
You could end up like Tony Stark. You could end up like Rob Tiffany. You never know how that's going to play out. So we'll see. Just go for it.
I'm aspiring to turn out like Rob Tiffany. So
but be careful, because look what I got a haircut, which was ridiculous because I had the Dave Grohl thing going, and now I regret it. I really do.
Yeah, I would. I remember I used to have hair all the way down to the middle of my back.
Wow.
And I got it cut, and that was the most painful day of my life. I will tell you right now. Yeah.
That is painful.
Yeah.
Not feeling the love there.
So today, we're not going to talk about Ericsson. We're going to be talking about Moab Foundation and its charter. And Rob, do you mind sharing a little bit about what Moab Foundation is and why you founded it?
Yeah, absolutely.
The backstory.
Yeah, the quick and dirty of Moab Foundation, it's a combination of a couple of things. It's IoT, digital connected intelligence technology, combined with, if you're familiar, United Nations has their Sustainable Development Goals. There's 17 of them, and the plan is to achieve all of those goals by 2030. Needless to say, we're way behind on most of them. And so the struggle is real for the next decade. But, part of that backstory is just, if I go back halfway through 2018, I did a startup for a short period of time before I ended up joining Ericsson instead. I created a startup called Enterprise IoT. You might remember that. And,
of course I do.
And so since I built Lumada, built a couple of versions of that, designed V3 and everything, and I had a lot of ambitions in my mind for the ultimate enterprise class IoT platform. And so started Enterprise IoT, and I started building this platform, which I just called it Moab. It's in reference to the town in Utah where all those beautiful arches and canyons are for hiking. So started building that thing. And so really serious enterprise class system based on all my years of knowledge and everything I'd ever done in this IoT space, and all the pitfalls I'd seen, the things that people wanted, trying to put all that stuff in there. And as being a person who's been a product manager, but also an architect and a developer, and I was rusty, but I could still code. I think I got better over time, which was good. So started building that thing. And ultimately I was being recruited by Ericsson that whole time, and I ended up taking the job with Ericsson. But I got the product to about MVP stage, Moab. And I got to the stage where I probably would have had to begin the process of talking to VCs, to maybe, I'd put in maybe $70K of my own money into that kind of seed stage. And it was time to maybe go look for a Series A. So anyway, off doing the job at Ericsson, and this code's just kind of sitting on a laptop somewhere and in the cloud. And I remember going to events that you and I have gone to, like IoT World Congress, the little mini-me version of Mobile World Congress, but in the same place. And I kept running into people who somehow knew about what I'd created. And they were asking me, hey, whatever happened to the code you built? I had people asking me for the code. I had people who've created, their own version of a venture studio or a Y Combinator kind of thing, asking me, hey, I'd be happy to shepherd that code for you and make it come to life, since you're busy with your day job, right? So I started thinking about that, and I started kicking around, looking at the code again, kind of on the weekends type thing, and got reinterested in it, even though I was kind of heads down working all the time, building this IoT studio in Santa Clara for Ericsson. I guess part of the backstory was, you're doing this IoT stuff, what it can do, in a simple form. It's, we've got machines, sensors, environmental systems that are, telling you what's going on in the world, in the environment, and you're pulling that data back and you're analyzing it and you can take actions on it. And I'm always thinking about that in terms of business and industrial and what are those outcomes. I started finding myself reading and being involved in stuff with the environment, with climate change specifically, and with water stuff. I had been giving money to water.org for years and was really into that and seeing all the issues we have with water shortages and how many people, especially women, spend maybe 4 to 6 hours a day just trying to go get water from a river and bring it back to the village. And that's what they do every day. And how people don't have access to good sanitation and food and so much stuff. And so I started kind of putting those dots together, thinking, is there a place for this IoT technology to make a dent in some of these areas? And so I found myself doing panel discussions, where it was all about environment and using IoT. And so I just started educating myself more and more. And then it's kind of started to turn into a little bit of a passion, to be honest with you. And then I kind of look back at all that code I wrote, and it's like, well, gosh, maybe the right thing to do is to take this technology and find a home for it with folks who are trying to tackle all these problems in society and in the environment. I stumbled upon the United Nations Sustainable Development Goals. And, analytically, my initial perspective was, hey, if nothing else, this is great. It's 17 categories to kind of divide and conquer, and I can look at the ones that not all of the categories make sense for IoT. Obviously, you can't just pound a square peg in a round hole if it doesn't make sense. So it helps you to focus. I'm going to focus on SDG1, poverty, and I'm going to focus on hunger and water and climate. And then I can start going through off the top of my head and go, hey, what are the use cases where IoT can make a difference? So it really started like that. Then back to the technology, I started the process of stripping out and kind of rebuilding Moab because it was really complex, really serious, giant enterprise thing. And I was thinking, I need to make something that's simple, something that I can put on a little tiny edge device. I always think of those little Intel NUCs computers, something that, I tell you, let me give you a prop here. I was really inspired many, many years ago. I don't know if any folks remember this. United Nations a long time ago did this thing called one laptop per child. And they created this thing. It's like a play school toy with Wi-Fi. But the idea, there was this effort to try to get the idea of $100 laptop. And now we're talking a long time ago, and so it was really hard to pull that off. But what was my takeaway for me was, you can really move the needle for people with simpler things. In business, everybody's talking about machine learning and deep learning and AI and blockchain and all this stuff. And I realized I could make a big difference in the world with simple stuff. Kind of like this is simple stuff to help kids, in developing countries. So I started stripping down Moab and making it simple, making it small, making it understandable, so that I could give it to nonprofits, non-government organizations, NGOs, who are actually going after these sustainable development goals and need help. Obviously, these folks, unlike big giant corporations, they don't have a lot of cash laying around. And so economics is a big deal. And so it's like, I'm going to create this technology and I'm going to give it away. But it's not enough for me to give away the software. I know hardware costs money. Someone's got to pay, right, at some point. Right. And so make sure that it can run on low-end hardware. Created the nonprofit, this 501(c) for the Moab Foundation, which grew out of that, with the thinking of, for the start, I'll spend time with me, but more importantly with experts in the different SDGs to come up with the use cases. I often say, and I know a lot of other people often say, the technology is the easy part. Coming up with the right use cases, coming up with a plan to execute on that successfully. How do you do it? What are the challenges? That's the hard part. And so the Moab Foundation grew out of that. And so that's what it is, working with smart people, figuring out the use cases. And ultimately, it's going to take people, volunteers, because, when you want to go deploy some solution in some part of the world to help them, you need a few things. You'll need electricity. You might need wireless coverage. because you're going to have compute, storage, all that, and then you need volunteers. And so the nonprofit idea is the ability to, if we're doing something, we'll need to raise money to do that.
Mm-hmm.
But in other cases, we'll just give the ideas and blueprints and the technology itself to other people who are going to go do that on their own.
Yeah.
I know I'm kind of rambling, but there you have, that's Moab backstory kind of in a nutshell.
No, that's great. I think the question our audience is going to have at the moment is, where did you get that?
Where did I get what?
The laptop for all unit. Did you buy it, or I mean, how did you end up with that?
Yeah, no, that's a great question. So it was Nicholas Negroponte was the guy who pushed this with the United Nations many years ago. It's like a primitive version of Linux, I think, from the 90s. It's all sealed in. It can be covered in mud and dirt, and uses, remember ad hoc Wi-Fi, where we're just kind of peer-to-peer with your classmates in your school. You may only have one connection in your village, right?
Yeah.
When things didn't go as well for them trying to hit to that $100 laptop, what they did for a while was this program called Buy One, Get One. And so it's like, I would pay a lot more money to get one of these to donate to some kid in need, and I would get one too.
Mm.
So that's how I ended up with one of these fun little things. And
wow.
Easy to carry and everything.
Yeah.
And obviously this kind of hits home right now with COVID, doesn't it? Kids need laptops, don't they?
Forward thinking. Yeah, big time.
Yeah. And it was and back then, what was it about? It was mostly for education. We need to deliver education remotely to kids in underserved areas and remote villages, in deep poverty. And guess what? Here we are again today.
Yeah. And ironically, we need it in the United States, not in some developing country, right?
Yeah, absolutely.
I think that's great. And I completely agree with you that one of the key things is to be able to help folks figure out what's the path to innovating with the technology. Technology itself doesn't do anything. You actually have to build applications. And I think you've probably seen some of my recent posts on LinkedIn. I think that's where people get confused. You have to build applications in order for the value of the technology to be expressed in some way. And I think, that's great to have those blueprints and providing technology for architects and solution people, problem solvers, to basically use the technology and making something good happen and helping to further these goals, right? The SDG goals. So I wanted to really quickly point out to our audience that Rob did a great talk at the most recent, actually it was last month, IoT Communities, IoT Slam 2020. So Rob, you did a presentation on analytics and the SDG goals, right? And so I highly encourage our audience to go and check that out. Just go to iotcommunity.net and you'll be able to find that session there. And you did this incredible job of running through all 17 of those goals, which you'll put up right now. So folks, these are the 17 goals. And Rob actually, within, I think, about 30 minutes, managed to systematically go through each one of them and highlight some of his thoughts. Well, you did something really clever. You clarified the problem, the scale of the problem, and then you suggested some solutions to them, right? And so definitely check that out. It's thought-provoking at the minimum. So,
I appreciate that.
Great.
And you know what? It was definitely a lightning round of trying to get through so many so fast.
Yeah.
Clearly, I was just barely hitting the tip of the iceberg. I wanted to just do, one or two things.
Course.
But I hope it inspires thought of other people who are a lot smarter than I am in those different SDGs to really take some deep thought and pitch. Again, this is all hands on deck, volunteer effort.
Right.
And so we need all kinds of bright people from all directions to help out. The other thing you notice is some of the solutions, there's a lot of overlap between a lot of the SDGs,
dependencies
poverty and hunger kind of, and water and sanitation, they all kind of, a lot of the same solutions are the same for all of them. When you find out that so many people who are the most poor people in the world, they're also in agriculture. That's how they make a living and put food on the table is they're in agriculture. And so it's like, what can IoT do to help increase the crop yields or things like that?
Yeah, I mean, I think that there's let's say, a more simplified problem architecture and solution architecture underlining these 17. Like you're saying, there's the overlaps. You could probably distill all the different types of solutions to address the 17 goals with maybe like 5 or 6 key solution patterns or solutions. Not saying that it's 5 or 6, but it's going to be probably a smaller number than we would think. And
Sure.
so I think that was one of the things that you and I discussed about is probably this importance of thinking through all the 17 and figuring out, well, okay, if we were to look at these problems holistically or these goals holistically, now what would a solution look like? What would a solution architecture look like to address all of these goals? And what are, how do we kind of rationalize the overlaps into something that's much more simple and crisp for solution architects to now embrace and then, build? Because that's what we need to do, right? But I think you did a great job of basically helping people think through, at least goal by goal, how could we apply IoT in a way that's going to further the goal? And so I thought that was really well done. But one of the things I wanted to talk to you about, Rob, we talk about digital twins all the time, and I know that digital twin is an important element of the technology that is Moab Foundation, right?
Sure.
So I wanted to see if you could share with the audience some of your thoughts on, well, number one, what is a digital twin really quickly? And, maybe what we can do is refer to folks to some of the stuff that you and I have done on other podcasts, whether it's IoT Coffee Talk or what have you.
Sure.
But what is digital twin, and why do you see it as something that matters in the context of addressing the UN Sustainable Development Goals?
Oftentimes you'll just hear the simple example of digital twin is the digital representation of a physical object.
Yeah.
Is usually the first thing you hear. It could also be the same thing of a subsystem of an object, or it could be something that's bigger than the object, a group of things, a process. In IoT, especially as I've watched it over the years, it's just kind of this data streaming in, it's arriving, it's in some data format, or it's ending up in rows and columns, and you're doing some kind of analytics. I just noticed that the idea of a digital twin, and it doesn't necessarily mean I'm talking about some 3D CAD model. That's one end. You don't have to do that. But the data about it really helps people wrap their minds around what they're looking at. So if I'm talking about a car, I love to use car as an example for a digital twin. I start at a higher level, though. I have something I call a digital twin model. If you're a geeky programmer like me in those object-oriented programming, you might think of a base class.
Right.
That says, at a high level, I have a Mercedes ML350.
Mm-hmm.
And I'm going to define the properties of that. And so you can, in your mind, you're thinking, okay, I'm going to define properties for the 4 tires, tire pressure, aspects of the engine, the oil pressure, temperature, RPMs. If you ever sit in your car and you look on your dashboard, especially newer cars, there is so much data displayed along with just your normal speedometer and everything like that than you've ever seen before. In fact, I've seen a lot of cars where you have to keep hitting this arrow to see more and more data. That's really what IoT is. There's these sensors and it's information. And in the past, we've always had that information locally. Yeah. All we're doing with IoT is we're remoting that data somewhere else so I can centralize it and see it somewhere else and analyze it. That's really all it is. Yeah. So if you think about your car, all that stuff, I'm gonna create a digital twin of that model of that class of car and everything about it. But then I'm gonna inherit from that. I'm gonna create digital twin instances of your Mercedes ML350 and mine and somebody else's. It could be any kind of car, right? It could be a Toyota, it could be a Kia, it doesn't matter. And so then there's the instance of it, and it's gonna inherit all those kind of properties from the base level object, right? The asset class. There's an organizational reason you do that initially. I've seen lots of IoT platforms in the past where every individual device, car, sensor, whatever you had to configure, you were defining properties for each one over and over and over and over again, even if they were all of the same type. And it started to get really tedious. What if you had thousands of those things? So it's easier to define it once, inherit from those for the instances, and then to geek out further on those properties of, we'll just stick with the car, the tire pressure. You'll also define things like what is the unit of measure from tire pressure? In this case, it's PSI for tire pressure. Right. For engine temperature, it's temperature. Right. For the speed, it could be acceleration, all kinds of stuff like that. So you need to define the unit of measure. You will also define the data type. What is it? An integer? Is it a number? Is it a string? Is it a floating point? Whatever. Is it an object with other things? The reason I say all this, and it's not to just be a total computer nerd,
which you are,
but there's a reason we're doing this, because my tagline with IoT is connect, collect, analyze, act. Yeah. Well, you can't analyze the data you collected if you don't understand what's coming at you. And so all this data is flying into let's say your IoT platform and arriving, and it's being stored in a database or something. But your analytics to derive some insight that's valuable to you, either as a company or achieving one of our sustainable development goals, if you don't understand the shape of the data that's coming at you, that sometimes you might hear about data labeling, especially machine learning and stuff like that. So the first thing is your analytics are like, okay, here comes data from device number 75. Yeah. What the heck is that? Oh, it's this Mercedes ML350. That's what it is, and it belongs to Leonard. And there's all these properties. What are those? Well, there's labels for each one. Right front tire pressure. Oh, great. And there's a value that comes along with it that says 32. Well, I don't know what that means. Oh, it's a type, is a PSI, it's pressure, and it's an integer, or it's a float. Right. What you're doing is you're empowering your analytics. And this could be simple analytics, or it could be machine learning. You're trying to give your analytics the best possible chance to succeed. And so that's why it's so important to do all this extra work, because ultimately this is all just metadata about your thing, right? And so you're helping your analytics, so it shows up. The analytics can, we've heard, if you're a database person, in the past you thought about things like a data dictionary and stuff like that. I'm providing a dictionary for the analytics to say, hey, here's what's coming, here's what it all means. And so your analytics go, oh, that's what it is. I know how to do appropriate calculations and whatever it happens to be, and to come up with an insight. So that's at the kind of the most basic level of what digital twins are doing. There's way more than that. Right. I've written lots of articles about all the crazy things you can do with digital twins. Yeah. But that's kind of the baseline.
And I mean, I think it was pretty recently that Rick Bellotta suggested methods in characterizing behavior of digital twins, right? So that you can have these digital twins actually suggest what kind of behavior and interactions that they can have with other digital twins. Yeah, because, when you create that twin and you have all those properties defined and all the stuff I just talked about, the next thing you can do is and we'll just keep it simple, you could define KPIs, key performance indicators, or threshold ranges, just to keep it simple. Back with a car, if the temperature gets too hot, it goes from yellow to red, right? KPIs are things that people do in corporations. So you could define, hey, for this property, for right front tire pressure, I'm going to define KPIs that say the green zone is between 31 and 33, and the yellow is from 27 to whatever, 35, and then red is even farther out, too low or too high. And so I define those in that digital twin. This goes back to giving your analytics help. So the analytics understands the data, it sees the actual value for the tire, it knows what it means, and then it looks at the KPI you defined, and it compares it. And it says, 37 came through as the value, and I'm doing a KPI, and 37 is in the red zone. So that's no bueno. Yep. And then I can fire an event. I could take an action that says, hey, I'm in the red zone. I need to alert the driver. I need to send a command to maybe tell the car to slow down, whatever it happens to be. Yeah. Well, if you have that intelligent control loop, all of a sudden you have an autonomous system or an autonomous function, right? Yeah. And you really do need to have that digital twin in order, from a data and schema perspective to really enable that.
Absolutely. So in my
Yeah, that's a
mind,
light bulb that just went off
it
on my
is a
head.
light bulb. And so in my mind, so much of this technology, obviously
Yeah.
you need the connectivity, right? But
Yeah.
digital twins are defining the what.
Mhm.
APIs are the connective tissue between all these
Right.
things. And then agents or bots or whatever you want to call it that bring that stuff to life. It's that bot, API data streaming in. Twin says, this is what you're looking for. The bot says, I looked at that. I saw that. It means this. I'm going to take an action.
Mm-hmm.
And you put those three together, and now you've got a system, right?
Right.
And now you've built your autonomous vehicle. I'm sure it's that easy.
Oh, it's totally that easy. And I think from a developer's perspective, as they start to look at their environments and the solutions that they are looking to build, they can use these digital twin definitions to start thinking about, well, what data do I need to collect? You talk about hydrating digital twins all the time. Well, you also need to have an idea of, if I want to solve a certain problems and these entities are involved, in order to architect a solution, you need to also think about, well, what data do I need to collect, and then actually instrument the real world, right? And so it's almost like you can use these definitions as a blueprint for, you mentioned blueprint, for thinking forward. So actually, it might even be thinking backwards, because we assume that when we implement an IoT solution, we're going into sort of a brownfield environment where things are already out there that are instrumented or what have you. You're just trying to make sense out of data that's already available. But in some of these new scenarios where you're trying to innovate new solutions for problems that are associated with these sustainable development goals, well, you might not have anything instrumented. You have to figure out, okay, well, what data do I need in order to enable this solution? Let's say that it's one of the examples that you often come up with is a field, or and maybe it's a certain kind of crop that has certain characteristics. Well, what are those data points that we need to have in order to enable the IoT benefit that we're looking to design and implement? But then what do we need to do to get that data? Right?
What are those?
You can have a digital twin and it says, hey, look, we architected this canned solution for you guys. And then you go out and you can't figure out, well, how do I get the data? All this fancy IoT stuff doesn't make any sense.
Absolutely. You might create a digital twin model of a Honeycrisp apple tree. And then you will have digital twin instances of thousands of apple trees in an orchard in Eastern Washington. And then you're right, there's the properties of those trees and what they need to thrive and to produce as many apples as possible, right? And then you're right, that leads you to, okay, I'm going to need to go get sensors to tell me air temperature, leaf moisture, humidity, soil moisture, and maybe really deep underground soil moisture. That's trying to keep it simple. There's more advanced things where you're doing spectral analysis to see different colors and can tell if there's any disease and things like that. There's amazing sensors that can detect gases, that can detect bacteria, that tells it, hey, this is the most ripe time. You should harvest right now.
Right.
So you're right. There's all kinds of stuff like that. And so you're right. It leads you to that. And so that's how all this is going to work. We've got to get sensors, but the sensors are connected to some kind of little microcontroller or a little tiny computer. It needs to be able to run for a long time unattended. So on battery, maybe it needs solar if you're putting it out in a remote location. If you don't have cellular coverage there, how are you going to get that data back to wherever to analyze it? You might be doing mesh networking. You might be using LoRaWAN and creating your own network. Who knows? But those are all the skills that you need. We often talk about a giant skills gap in IoT because it's a multidiscipline thing, right?
Oh, yeah. Well, I mean, Rob, I was just thinking, that field agent or worker, UN field worker or rep or whatever they're called, working out in the field, trying to figure out, okay, how do I enable and use IoT for Sustainable Development Goal number 5. I don't know what that is. I don't have the chart up. But,
Gender equality.
Okay. Yeah. Hey, that's a good one. That's a tough one.
Yes.
So yeah, it's how do I take all this techno geeky stuff that Rob knows and actually figure out how to solution it out on the field, right?
Yeah. No,
and that's really the other big gap. It's not just the skills gap. It's just simply the knowledge gap.
Yeah.
I think.
Yeah.
And I think that's what needs to be bridged. And hopefully we'll have a lot of chances in the future to work together on bridging those gaps, because I think that's really what's holding a lot of stuff back, and what could be a big challenge for applying IoT to enable these SDGs. Or among other things that you list out on your wonderful presentation for IoT.
No, you're right. Yeah, there's so much education that needs to be created and delivered in an understandable way.
Yeah.
Where people can take action on these insights, right? And know what to do.
Yes. Talk about how our audience, for our audience members who are interested in getting engaged with Moab Foundation, how they can go about doing that, how they can get involved with some of the initiatives that you're working on. And, for developers, what are some of the benefits that they can get? Maybe you can show a little bit of platform.
You may turn my camera here and look at my, all right, let's see.
Wow.
That looks there. And I'm going to zoom in. And hopefully this all works out. Okay, so looking at a screen. To start learning more, and it's a work in progress, but you can go to moabfoundation.org is the website. There's also stuff on LinkedIn and Facebook and Twitter and stuff like that. There's your beautiful view through the Mesa Arch in Canyonlands in Moab, Utah. But yeah, you get right down to it, and it just kind of jumps to the simple thing. What is it? We want to combine thought leaders who have expertise in these different SDGs and create these use cases and then execution plans so that we can make an impact. So that's step one, and then provide this Moab platform that I've created and give it to those folks who are going to execute on those actions, right? To learn more, you go down here, right here, just a little quick and dirty. How do we achieve these things? We start by connecting people, machines, environmental systems, and start getting that knowledge transfer going. We capture that data, and maybe we turn them into digital twins. I always love, when I think about what IoT does, making the invisible visible, making the unknown known, and things that are remote are now local. That's what IoT does for us. And that's really a powerful concept. We take that captured data, we digitize it like digital twins, and it could be a little thing or it could be a big thing, a collection of things. And then we take those use cases that we can make an impact. And then ultimately it's people, it's volunteers. It's going to be some fundraising because as you brought up, there's sensors to find out about that world around us. There's computers, there's networking, right? And so electricity, we need all that stuff as well. And those are challenges. And where you're going to do these things, can I just march into some country and say, I'm here to save you? No, you probably need you need to work with those countries to get in. If I click on any one of these SDGs, we kind of give you some good definitions. And you know what? This is new for a lot of people. The Sustainable Development Goals, not everybody knows about them. For starters, you can click on any one of these and just learn at a high level what these are all about, unrelated to what I'm doing or IoT, just learn what it's all about. And then over time, we'll be building out the use cases that apply to these particular Sustainable Development Goals. This would be a good reference to get going. Starting out, go here. You can obviously reach out to me, rob.tiffany@moabfoundation.org. And then for fun, let me... I have a little application here. This is the home screen. So let's just create an organization. Let's just start for fun. Does your audience know what multi-tenancy is? Anyway, this is a multi-tenant system. It means one system, one computer can handle multiple companies, organizations, whatever. You don't have to just do one at a time. Usually when you think of multi-tenancy, you think about cloud type stuff. But I thought it was important to make it have that. So let's create an organization. Poverty Stoppers. We're going to stop poverty everywhere. You're the CEO of Poverty Stoppers, Leonard.
Thanks for volunteering me.
Yeah. And I'm going to say you're Leonard at mail.com. And we'll just do a simple 1, 2, 3 for your password. All right, so I'm going to log in. That kind of pops up. If you see any of your IoT systems, basically I'm giving your identity a unique identifier number and an unique security token that's used in the system. In here, you could go in and you could, there you are. You could go in and create more users of the system. If you have other people, part of your organization that's working with this, you can add those users to the system. This is to administer the system, basically. Groups are always helpful. A real simple thing. We're back at our orchards, right? With our apple orchards. Maybe, I have different orchards in different parts of my farm. I might have an orchard in the North 40, right? Over there. And so you create groups because you want to group your things, your digital twins of your physical entities to organize them, right? To know where they are. I talked about digital twin models. I won't go into all this stuff, but if I say Toyota Corolla, small car, and I'm going to create a model, and also I have a version of this. And the reason I do versioning is that car could change over time, or its capabilities or things, or new model versions or years and things like that. And so you may not get it right the first time. And so, you'll create versions of that. And then through these things, as we talked about, like if static properties, a static property is unlike what we talked about before. It's things that don't change very often. So I might create a static property, say the car is 20 feet long and it's yellow. Or actually, I wouldn't say what color it is at this level because it's a base class. But there's a lot of properties of things that don't change. That's where you would add those there. Telemetry properties are exactly what you and I talked about earlier. Tires, pressure, all that stuff. Virtual properties are interesting. There are properties that don't have a one-to-one connection with a sensor, and you calculate what it is. So for instance, how fast you're going, like miles per hour or kilometers per hour, there's no such sensor as that. It's a calculation based on RPMs and a few other parameters, and they put all those together to tell you, oh, this equals 20 miles an hour. So there's virtual property. If you're a database geek, you might have remembered doing calculated columns in databases.
You could use that in sensor fusion function.
Yeah.
Really easy.
Yeah, that's right. Yeah, because you're going to do a mashup of one or more sensors and then maybe some reference data from your static properties. Or it might be something where you're calling an API to pull in some other data from somewhere else, right? Do data blending from other data sources. And then we talked about KPIs. I'm going to set the KPIs for this car. And so for all its dozens, hundreds of properties for things that we care about, I might create red, yellow, green KPIs and define them for each one of those. As some data science-y people would say, it's a massive multivariate system because there's lots of telemetry and lots of data points from each thing coming all the time. And then you're looking at each one of them in so many different ways. So this is where you would create the model of that. And then if I was going to just create a digital twin instance, your Toyota Corolla, Leonard's, and so brilliant stuff. And notice that I've got a drop down here that will show me all the digital twin models I've created. So we only created one, but if I had a bunch of them to inherit from, I would choose there. And then what group is it in? Obviously, North 40 doesn't make any sense with cars since that's back at our apple orchard. By default, there's a global group. And then whether this thing is enabled or not. And this is critical. Back to security and hacking and all that kind of stuff. If your sensor, your device gets compromised by hackers, you want to disable that and not accept that telemetry in. And there's lots of other security that goes into here with the security tokens, rotating security keys, outbound only connections from devices. Obviously, you're doing TLS over the air. The data on the device is encrypted as well. So lots of security is thought about this. But this is a simple one. Just if I need to blacklist a device because it's been compromised, I can do that. And so I'll create your car. And then I could do specific static properties of your car, and so in this case, I might say your car is red because that's unique to your instance of it. And so you can imagine that. Folks may have heard the term digital thread. Digital thread is basically looking at the entire life cycle of that thing, in this case, the car, from when it was designed and produced and then in its operation until it's retired. So this is kind of a PLM thing, product lifecycle management thing. So all the telemetry that's captured all the time historically is this giant long digital thread that tells you the story of the machine. And then sometimes, though, there'll be a manual digital thread event that you'll need to create yourself that's not coming automatically from telemetry. So, for instance, on your car, you might say, oh, I took it to Jiffy Lube to get the oil changed at 23,000 miles, and I got a new fuel filter and but other stuff. You could click digital thread event and manually type in that so that that's added to the story of your machine. I often, when I talk about digital twins, I often refer to them as the digital version of the owner's manual that you get when you buy a car, because that's really what it is.
Oh, okay. Well, Rob, I just want to know when I can take delivery of the car.
Oh,
any date, promise date?
Now. Go down to the port of San Diego. It's waiting for you with about 1 million cars.
Oh, man. Okay. Well, hey, Rob, thanks for stopping by and sharing your vision for Moab Foundation. You know, I'm really looking forward to working with you.
Yeah, I'm glad to have you on board.
Yeah. For full disclosure, I'm an advisory board member. It's a great honor, and I'm sure we're going to have a lot of fun. Absolutely. And so thanks to our audience for joining us in this discussion, and feel free to comment and share your thoughts and reactions to this podcast, and press like and share. And if you haven't already, please check out our research blog at www.next-curve.com. Also subscribe to our YouTube and Apple podcast channels. Just search for Next Curve. And Rob, great to have you again. We have to do this more often.
Absolutely.
And we talk to each other every week anyways, but you know, we'll have to pick some really cool topics to bring you back on and chat and talk shop.
Sounds good.
All right. All right. Be safe and keep healthy, everyone.
Excellent. Thanks for having me.
Visit us at www.next-curve.com.